Welcome back, everybody. This is our Algebra 2 Function Foundations lesson number 4, Domain and Range of a Function, Homework Review, Part 3. In the last lesson we did for homework review, we ended doing a little bit of talk about interval notation, so I kind of want to talk about it here, a little bit here. But before we start, I want to ask you guys, please give a like to the video if you find it helpful, if you learned anything or just in any way. I appreciate that. And of course, if you have not subscribed yet, please subscribe and turn on notifications so you can find out when new videos are added to the channel. And of course, please leave feedback, questions, comments. We'd love to hear from you. So interval notation, interval notation is a way of writing subsets of a real number line. A closed interval is one that includes endpoints. For example, the set x such that -7 is less than equal to x is less than equal to 5. To write this interval notation, we use closed brackets, little rectangular brackets, and we do -7 comma 5 closed bracket. And so the idea is that the endpoints are included, and this only works in this case of including all the numbers in between, not just integers. Every real number in between, which includes decimals and rational, irrational numbers in between, so all real numbers. The use of the interval notation is because you have this continuous of a set of values in between, so there's no breaks in between there. So okay, and if we're not including endpoints in interval, for example, y over y such that -2 is less than y less than 3, we will use open brackets. So it's almost like parenthesis, we call them open brackets. So here, open bracket -2 comma 5 close open or sometimes called soft brackets. Okay, so hard bracket, soft bracket, closed bracket, open bracket, it's kind of the idea. So the idea is if you have the squarish ones are include the endpoints, and the parenthesis looking ones look like for we don't include endpoints. So let's try a few of these, kind of write the following interval notation. And so here, we see that for the first one, all values of x such that 3 is less than equal to x is less than equal to 10. And we have here the equal sign here. So these equal signs mean we're going to be using, in this case, the hard bracket. And we're going to have 3. You know what? I can type this out. I'm most definitely going to type this out. So let's see if I can make sure I get this here. Okay, hopefully it'll behave. Yeah, well, there you go. Okay, so hard bracket 3 comma 10 close hard brackets. All right, here we go. Okay, so now the idea is in this case is that we are going to include the 3 and the 10, all right, because those are the endpoints, and we're going to including them. We use the hard brackets here. For the second one, is all values of y such that -10 is less than y or is less than -1. So we're not going to include the -10 or the -1. So we would use a parenthesis here. So -10, okay, open bracket, comma, -1. Okay, so here a little bit here, okay. And so we see here in this situation that because we're not including the -10 or the -1 in our set of values, but every number up to -10 and up to -1 in between, that's what this interval means. And then, so what happens when you have something mixed together? Okay, so here for C, Z, all values of Z such that -5 is less than equal to Z and is less than 7. So now the hard bracket, we're definitely including the -5, but we're not including the 7. So what we would do is the following, okay? And we can mix it up because in this case, sometimes intervals will include one endpoint but not the other. So since we are including the left endpoint, that'll be a hard bracket. Oops. Here we go. Then -5, comma, 7, but we're not including 7, so using the open bracket or the soft bracket. And this is how you would describe here, -5 less equal to C, less than 7, so not including the 7 at the end. So hopefully this is helpful to kind of interpret our interval notation. All right? Right, so I just wanted to go over this because I don't know if we, I want to make sure that this comes up quite a bit, and I want to make sure that we have a little practice in this and talk about it as well too. Question number 8. Which of the following represents the range of the quadratic function shown in the graph below? Okay, so the range represents all the possible y values. We see in this case the arrows of our graph are pointing downwards. So here, we see here, ladies and gentlemen, this arrow pointing down and this arrow pointing down means that the graph will continue traveling downwards without stopping. Okay, so we see here, we would talk about our y value would keep going on for the left side. So, but it reaches a maximum value here. And so this maximum value is going to be at a y value of 1, 2, 3, 4. Okay? All right, and so this is the highest y value. It doesn't get any higher than that. So we're going to interpret this as the following, that our range will be all values of y such that for y is going to be less than or equal to 4. Okay, so again, the idea in this case is that y will include every numerical value up to positive 4, but not including it, but not going any further. Okay, and so one might say in this case, well, how do we show this into rotation? We just talked about that now. Okay, well, we definitely have a rightmost value, and that's 4, and we're including that. But what is the leftmost value? Well, we don't have a number it stops at. So we talk about this idea of negative infinity. Now, negative infinity means to decrease without bounds. Keeps going on and on, keeps going to the left. It goes more negative, more negative, more negative, more negative, without stopping. And because it never stops, we're going to give this a open bracket because we can never reach that value because there is no endpoint in this case. So there's two ways to write this. The first in this notation, y is less than or equal to 4, or in this case, interpretation, open bracket negative infinity, comma 4 close bracket. Okay. Number 9, child starts a piggy bank with $2. Each day, the child receives 25 cents at the end of the day and puts in the bank. Not so bad. That's pretty good. If A represents the amount of money and D stands for the number of days, then A of D equals 2 plus 0.25D gives the amount of money in the bank as a function of days. So think about this formula, okay? So every day we're adding 25 cents, which in this case for $1 is 0.25. So if we have, in this case, after 3 days, we would have $2 to start off with at 2, adding 3 quarters, 3 25-cent pieces, and so it'd be $2.75. So the idea in this case, so A of 1 would mean in this case, we're going to substitute the D for the value of, substitute D with the value of 0.25 times 1, and that would be 2.25. And so that's the value that the child will have after 1 day. So a 7 would mean how much the child has after 7 days. So 2 plus 0.25 times 7. Well, now 7 quarters is the same equivalent to $1.75, right? All right, so $1.75 plus 2 would be $3.75. I should put that little symbol there. Okay. All right. And then A30, after 30 days, we have 2 plus 0.25 times 30. Okay, so what's 30 quarters? Well, I know every 4 quarters is going to be $1. So I think 4 goes into 37 times. 4 times 7 is 28, so that's $7 with a remainder of 2, so it's $7.50. 2 plus $7.50 is going to be $9.50. Okay, now we say what value of D will A of D be 10.50? So now to solve for this, we're going to set up our formula. So now A of D, the formula in this case is 2 plus 0.25D. But we're saying in this case, we're going to set this A of D equal to $10.50. So 1050 equals 2 plus 0.25D. Okay, so we definitely know it's more than 30 days. So when you could kind of figure out, well, we can figure out dollar more. So from we have here, it's $1 more than the 30 days. So that's 4 quarters. So we should get 34. Well, we can also solve as equation by subtracting both sides by 2. And we get 850 is equal to 0.25D. Divide both sides by 0.25. All right, and so now I can do a decimal slide here. So decimal slide 1, 2, decimal slide 1, 2. Now, how many times does 25 go into 850? Well, so D is equal to, it looks like 25 goes to 85 3 times. All right, 25 goes to 85 3 times. So we're left with, 75, 85 minus 75 is a 10. With 100, that's going to be 100 divided by 4 is 25, so it's 34, like we said before. So that would be 34 days. D is number of days. Okay. Now, explain why domain does not include the value D equals 2.5. So now, why can't D equal 2.5? Well, here's the thing, okay? Our domain is the number of days. Each day, the child gets one quarter. Our domain is made up of whole numbers. Okay, so therefore, 2.5 is not a whole number, and therefore not in our domain. Okay, so our domain is made up of whole numbers, and that's how we talk about this here. And so that's why you can't have 2.5D. So our D values are always going to be either 0, 1, 2, 3, 4, 5, and so it's all whole numbers, no decimals, okay, no negative numbers because you can't go back in time. So like yet. All right, so explain why the range does not include $3.10. Okay, and the reason why the range does not include $3.10 because the range, okay, the range is made up of values that begin at 2 and increase in increments of, well, 25 cents for each day. So that would mean in this case, the 10 cents, $3.10, let's see, here we go, $3.10 is a value we cannot get. Okay? Now, why can't we get this? Because we're getting quarters, like 1 quarter every single day. To have this happen, we would need to have add dimes, but this is not the case though. Okay, and so this is where we have to interpret our domain and come up with our, the domain is made up of the type of numbers we can have. Our numbers are, instead of quarters, being added to 0.25 increments, and because we don't have 0.1 or dime, it cannot be a part of our value in the amount there. All right, so it could based upon the rules we have for this problem. All right, ladies and gentlemen, thanks so much for watching. Please give this video a like if you found it helpful, and of course, also you can subscribe to the channel. I look forward to seeing you in the next video on our next lesson, and hopefully this will be helpful to you. Take care and be safe.